Hey everyone! In the previous video about building the outbuilding, I mentioned the lumber drying kiln. Today I'd like to show you how I built it. The outbuilding is 8 by 8 meters in size. Half of the space is used for storage, 1/4 is a chicken coop, and the remaining quarter will be dedicated to the lumber drying kiln. Alright, let's get started. I'm planning to do a concrete slab on grade floor, so first I need to prepare the base and clear out all the remaining debris. To mark the exact floor level, I'm using small wooden blocks. The laser level line shows up really well on the wood, making it easy to see the reference marks. Last year, I completely removed the entire topsoil layer here, about 20 centimeters deep. Right now I'm just leveling everything out. The drying kiln will be heated with wood, so I'm marking out the area for reinforcing the concrete slab where the stove will be installed. I'm not digging the stove foundation very deep, about 30 centimeters below the finished floor level. At the bottom of the stove foundation pit, I'm laying a sand base. The stove foundation and the concrete slab will be structurally independent from each other. I'm not adding sand under the main floor slab. Next, I need to lay extruded polystyrene insulation to provide thermal insulation and separate the soil from the concrete slab. Under the stove, I'm installing 100 millimeters of insulation, and under the floor slab, 50 millimeters. I'm sealing the joints between the insulation boards with adhesive foam. When pouring foundations, I often use large stones to save on concrete mix. These stones have been sitting in the ground for tens of thousands of years. Now they'll spend a bit more time in my foundation. Before pouring the concrete slab, I'm tying the rebar cage. Since the concrete isn't directly bonded to the ground, I'm using fiberglass rebar to save on cost. It's important to thoroughly vibrate the concrete to reduce voids and air pockets inside. But you shouldn't overdo it either. If you vibrate too long, the heavier components of the mix can settle unevenly to the bottom. Once the concrete has gained some initial strength, I start building the walls. It will be a lightweight frame made from battens and OSB boards. The floor is fully protected from moisture, so I'm building the walls directly on the concrete slab without any additional waterproofing layer.
Fundament natürlich schön. 6, 7, 8 штук.
I'm assembling the walls directly on the slab. It's very convenient. In fact, it's a standard stud frame structure, just built with thin battens instead of heavier lumber. To anchor the walls to the slab, I'm using concrete anchors. These walls won't be carrying much load, just the insulation, so I'm not worried about using heavy-duty structural fasteners. I've built several large timber frame structures, and honestly, these thin stud walls are much easier and more convenient to build. The largest wall I've ever had to raise by myself was 8 meters long and 4.5 meters high. That was an unforgettable experience. My circular saw doesn't have a blade guard. Don't repeat experiments like this. Take care of your health and your fingers. I'm completely sheathing the room with OSB panels, walls and ceiling included. Later on, insulation boards will be glued directly onto the OSB. Whenever possible, I try to use every offcut. Anywhere I can, I save material and minimize waste. For insulation, I'm using PIR panels. This is a polyisocyanurate foam insulation with foil facings on both sides. Installation is very simple. Everything is glued in place with adhesive foam. It bonds extremely well to OSB, so everything holds very securely. For the ceiling, I additionally fix the panels with screws. Once the foam cures, I remove the screws and inject a bit of foam into the holes. Inside, the humidity will be very high, especially during the first days of timber drying. It's important that moisture doesn't penetrate through the panel joints to the OSB, otherwise condensation will form there all winter long. I seal all the joints with special aluminum foil tape. Well, now comes the most interesting part. I'm going to build a brick stove to maintain the temperature inside the drying kiln. To save money, I'll be using reclaimed bricks to build the stove. These bricks were once used in a stove built by my great-grandfather. Now they'll serve me as well. I'm bringing the bricks inside. I've got a diesel space heater running here. The bricks need to warm up and thaw out before I can start laying the stove. While the bricks are warming up, I'm installing the supply and exhaust ventilation ducts. The fresh air intake is located behind the back wall of the future stove, and the exhaust is on the opposite side. I'm also installing a powerful fan in the room to circulate air over the boards.
Perfektnym obrazem.
I'm starting to build the stove. It's a complex process that requires knowing a lot of details and nuances, but since I work professionally in stove masonry, this isn't new to me. Old bricks can't just be used as they are. You have to remove any soot residue from each brick using a diamond grinding disc. Any course of masonry always starts with the corners. I check the diagonals first and only then lay the interior bricks. That way, the stove ends up as square and accurate as possible. I always design my stoves in Google SketchUp. It's fast and convenient. It lets me plan every single brick in advance. This stove will not only heat the drying kiln, but in the summer, it can also be used for drying herbs, mushrooms, and berries. For stove masonry, you always use a special clay sand mortar mix. And remember, the joints should be kept as thin as possible, no more than 5 millimeters. For the firebox, the area where the wood burns, I'm using special refractory fire bricks rated up to 1600 degrees Celsius. I always try to avoid using any steel elements in the stove structure. It's better to properly cut and fit the bricks so they lock together on their own without any steel banding or reinforcement. The stove has a fairly simple design, but to execute it properly, you have to do a lot of cutting and trimming of the bricks. All cast iron components in the stove are installed with expansion gaps to account for thermal movement. Otherwise, when it heats up, the cast iron would simply crack or tear apart the brickwork. All the cast iron parts are also second-hand. I restore their appearance by painting the doors with high temperature resistant enamel. For installing the cast iron components, I also use special heat-resistant basalt fiber. The basalt is used to fill all the gaps. It's acceptable to mount the doors using heavy-duty screws, especially if you plan to replace them later. However, the best method is to install a dedicated stainless steel mounting frame. Everything is ready now. Drying lumber down to joinery moisture content in this kiln takes about 30-40 days, depending on the thickness of the boards. This is because a brick stove doesn't produce very high temperatures, so the wood dries in a gentle, controlled way. That's it for today. Make sure to subscribe to the channel. There's a lot more coming: woodworking, stove building, carpentry, and beekeeping projects. Thanks for watching. See you next time.